This is a lesson on geometry of molecules. The geometry of molecules is determined by a theory that is the valence shell electron pair repulsion. Valence shell, these are the outer level electrons. Electron pair, electrons are in orbitals, so their pairs are 2. Repulsion. Repulsion means the negative electron orbitals want to spread out as far apart from each other as possible in three-dimensional space. So this is in 3D. Saying the valence shell electron pair repulsion theory is long, we abbreviate it VSEPR. The VSEPR theory is the same thing, that the electron pairs or orbitals spread out as far as possible in 3 dimensions. There are 5 shapes that you'll have to know, and you can determine these from the Lewis dot diagrams. You have the central atom X is attached to 4 other atoms. So on the Lewis dot diagram, if you have the central atom is attached to 4 other atoms, it is a tetra, which means 4, hedral, which means side, shape. So it's tetrahedral if it's attached to 4 different atoms. The bond angle is 109.5 degrees. If you have a lone pair of electrons, what it does is it pushes the bond angles together. So you have 3 single bonds, 1 lone pair of bonds. This is called pyramidal, and that is 107 degrees. It's smaller slightly because the electron pairs, there's 2 negative electrons in this 1 electron cloud, and it pushes ever so slightly against it. It doesn't make much difference, only 2.5 degrees, but it is detectable. The other variation of a single bond would be attached to 2 single bonds and 2 lone pairs. Now it can be in another geometry. Don't trust my drawings. If attached, these are still the same thing. This is a bent molecule at 104.5. Again, 2.5 degrees smaller than the last. All 3 of these involve single bonds. If you have, and it's attached to 4 things. If it's attached to 4 atoms, 3 atoms in 1 lone pair, 2 atoms and 2 lone pairs. They're still attached to 4 different things. There's 4 electron clouds surrounding the atom. If there are 3 electron clouds surrounding the atom, and that is represented by a double bond. The Lewis dot diagram has a double bond in it with 2 single bonds. Or if you have boron. Remember, boron's an exception because it can only have 6 electrons around it. This is a trigonal planar configuration, also known as flat triangle. It's easier to write flat triangle. And its bond angle is 120 degrees. So these are the only 2 cases that you have at. Notice that the central atom is attached to 2 different thing, or three different things. So if it's attached to three things, then it's a flat triangle. The last case is if it is attached to two things. There are three possible ways this can happen. You can have a triple bond with a single bond. You can have a couple of double bonds, or you can have beryllium. Beryllium, again, is another example of a small atom that can only hold two electron clouds for electrons. This is called linear, and 180 degrees. It's kind of obvious. Again, don't trust me on my Lewis dot diagrams. You can do this. It's still linear because it's attached to a single and a triple, even though it's at an angle. I would draw linear molecules at an angle. I would draw angled or bent molecules in a line. Yeah, make sure, look at that. In the last case is ionic compounds don't really have a shape because they don't form molecules. They're separate things. What you do is you have a positive, negative, 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 positive. So there's alternating positive and negatives in a thing. So there's no real molecule. It's just separated positive and negative things. I associate this with Legos. So it works like Legos does. That's the end of, that's the end of this lesson on geometry of small atoms.